We have with us Professor Babu Alapat from Indian Institute of Technology and New Delhi for the conduct of PhD pre-submissions of two PhD scholars. The first one is by Mr.Buddharatna Godbole under the supervision of Dr. P.V. Nagar Naik, and the topic of the PhD work is feasibility study of removal of fluoride from groundwater by various solid waste adsorbents. And the second one is by Mr. Ranjit Patil under the supervision of Dr. P.V. Nagar Naik only, and the title of the work is a feasibility study of defluorization techniques using forest herbs. So, with the permission of the expert, can we begin with the first presentation?
Buddharatna Godbole. My guide is Dr. P.V. Nagar Naik. The topic is feasibility study of removal of fluoride from groundwater by various solid waste adsorbents. As we know that water is the essential natural resources for sustaining life and environment, which we have always been known available in evidence and a free gift of nature. Chemical composition of a surface or a subsurface, geothermal or non-thermal, is one of the prime factors on which the suitability of the water for domestic, industrial or agriculture purpose depends. Groundwater forms a major source of drinking water in the urban and rural area. About 90% of the public depends on that. But in the era of economic growth, groundwater is getting polluted due to urbanization and industrialization. In groundwater, the natural concentration of fluoride depends upon the geological, chemical and physical characteristics of aquifer, porosity and acidity of the soil and rocks, temperature and the action of the chemical elements. It is a highly reactive. Geochemical characteristics of earth crust, which result from the volcanic and polluting activities, are the primary source of the fluoride. Water and food are the secondary sources. Industrial uses also contribute fluoride to the water table. In addition to this, fluoride has a great affinity with the calcium, silica and aluminate. These are the health effects of the fluoride. If concentration is less than 0.5, then it causes a dental caries. If range is between 0.5 to 1.5, then it promotes the dental health. If concentration is between 1.5 to 4, that causes a dental fluorosis. Then if it is greater than 4 mg per liter, then it causes dental and skeletal fluorosis. This is an international and national scenario. Fluoride affects worldwide, mostly 25 countries. Basically, if we say notably India, Sri Lanka, America, Europe, Asia, Kenya, China are the more affected areas. This dark region shows that these are the fluoride affected areas in worldwide. This reddish dark color shows that this is the highly affected area in the India. Rajasthan is the mostly affected area. Various methods are there to remove the fluoride from the water, groundwater. Few are this: coagulation precipitation, contact precipitation, electrochemical processes, membrane processes, reverse osmosis processes, nanotechnology, electrolysis, ion exchange, and adsorption. In our study, we have gone through for the adsorption process. These are some summary literature survey, where after the author, then adsorbent which are used, then C0 is the initial concentration, dose, pH, and then remark. So like this, I have gone through various papers. Adsorption. Adsorption is a surface phenomenon. Adsorption is a process that occurs when a gas or a liquid solute accumulate on the surface of a solid or a liquid, forming a molecular or atomic film. Here we can see this. Here we can see this. These are the adsorbent. This is adsorbate, and this is solute. This is another diagram which shows the three-step diffusion to adsorbent surface. We can see this is only on the surface, accumulation of particles on the surface. Here we can see that it is migrated towards some pores, and then this is the fully adsorbed. Then adsorption is two types of adsorption process are there. The one is physical adsorption, and second is chemical adsorption. Physical adsorption, the gas molecules adhere to the surface of the solid adsorbent as a result of intermolecular attractive forces between the solid and the adsorbent. And the process is exothermic, that the heat liberated in the order of the enthalpy of condensation of a vapor. It is up to 2 to 20 kg per gram mole. The process is reversibly. Physical adsorption is usually directly proportional to the amount of solid surface area. Then adsorbent can be adsorbed on a monolayer or a number of layers. The adsorption is generally quite rapid as compared to chemical adsorption. Now, chemical adsorption results from a chemical interaction between the adsorbent and adsorbent, therefore formed a bond in much stronger than the physical adsorption. Heat liberated during a chemosorption in the range of 20 to 400 kg per gram mole. It is frequently irreversible. On the deposition of the chemical nature of the original adsorbent will be undergone a change. Only a monomolecular layer of adsorbent appear on the adsorbing medium. Then these are the factors controlling the adsorption. Number 1, nature of adsorbent. Number 2, pH of solution, contact time, initial concentration, then temperature and degree of agitation. Then this is my objective of research work. To characterize the adsorbent like groundnut shell powder, GSP is groundnut shell powder, marble powder, MP, eggshell powder, ESP, then seashell powder, SSP for the physico-chemical and adsorption properties. To study the effect of various parameters like pH, adsorbent dose, contact time, initial concentration and temperature on the removal of fluoride for the aqueous solution in a batch study. To carry out the kinetic and equilibrium adsorption study for the adsorption of fluoride onto a various adsorbent, and to analyze the experimental data using a various kinetics and the isothermal models. To understand the thermodynamics of the adsorption and to estimate the Gibbs free energy, enthalpy and entropy. To check the desorption study, to check the possibility of disposal methods, and lastly to find out the breakthrough time in column study. These are the adsorbent which I have used: groundnut shell, marble powder, eggshell powder, seashell powder. These are the solid based adsorbents, solid based material. Then this is my methodology. These are my materials, adsorbents. Initially we have collected this and we have done some preparation on that material. Then we have performed 3 studies: adsorption characterization, number 2 batch study, and number 3 is column study. In adsorption characterization, I've gone through a proximate analysis, point of zero charge, then SEM analysis, XRF, and XRF is chemical composition, and XRD, X-ray diffraction. Then in batch study, effect of dose, effect of pH, effect of initial concentration, effect of stirring, we can say agitation, effect of time, effect of temperature. In column study, breakthrough curve at different bed depth, breakthrough curve at different initial concentration, breakthrough curve at a different flow rate. Once we have done this, then we have gone for the disposal method. Then we have studied 3 equilibrium isotherms and 5 kinetic models. And equilibrium, this is a Langmuir isotherm, Friendlich isotherm, and Temkin. In kinetic, pseudo first order kinetic model, pseudo second order kinetic model, interparticle diffusion model, Ilovich model, as well as modified Friendlich equations. This is a collection and preparation of material. I have worked on a very raw material so that can be helpful to a rural area. That's why groundnut shell and marble powder was collected from a neighboring market and having a high silica and a calcium content. Since I have selected a silica based material and calcium based material since it has a good affinity with the fluoride ions. That's why initially these materials were washed with the 0.01 normal HCl solution and allowed to dry in oven for 3 to 4 hours. The groundnut shell is washed with the deionized water followed by drying in oven for 110 degrees centigrade for 24 hours. After drying process, material is grinded with the help of a kitchen mixer, and after washing and drying process, material is sieved through a 75 micron sieve size. Eggshell is collected from my house only, washed it for with a 0.01 normal HCl solution and allowed to dry in oven for 3 to 4 hours. The further wash material is crushed in a kitchen mixer, followed washing deionized water, followed by drying on oven for 110 degree for 24 hours. After washing and drying process, material is sieved through again 75 micron sieve size. Seashell is collected and called from the chimney. Since seashell is a very hard physical, or initially it was crushed in a small mold with the help of rammer and then washed with the 0.01 normal HCl solution, allowed to dry in oven for 3 to 4 hours. Further, wash material is pulverized in a kitchen mixer, followed by washing deionization and deionized water, followed by drying in oven for 110 degree centigrade for 24 hours. After the developing of adsorbent, these materials are stored in the dry bottles for further use. The present study. Initially, characterization of adsorbent is done. In this, moisture content, ash content, volatile matter, fixed carbon, and particle size is done under this proximate analysis. We can see this ash content is very high in eggshell powder, and fixed carbon is very high in this seashell powder, and all the material are less than 75 micron sieve size. Then this is a groundnut shell. We can say this is a raw material. Then this is in the ash form after the oven. And this is a SEM analysis. These black spots shows that these are the pores available on the material, and this shows that this is a fibrous material. This XRD helps to support that SEM analysis. This shows that this is amorphous in nature, and then chemical composition XRD is done, from which we have get this is a silicon-based material. Silicon percentage is 43%. Then marble powder, this is basic material. This sharp edges shows that this is crystalline in nature. This black hole shows that this is porous in nature. Then this peaks show that this is a crystalline in nature. This supports that SEM analysis. Further, chemical composition is done, and here we are getting 34.34% of calcium. Again, this is the calcium-based material. Then eggshell. And this is the eggshell after mixing in the after crushing mixer. Again, we can see this SEM analysis. These are the very sharp edges, which shows that these are the crystalline nature. Again, this black spot shows that this is having a porous nature. XRD again supports this. This peak shows that this is the crystalline in nature. Again, chemical composition were done on this, and calcium percentage is 51.3%. So like that, out of 4 material, groundnut shell is a silicon-based material, and other 3 materials are the calcium-based materials.
Could you repeat?
Out of 4 materials, groundnut shell material is a silicon-based material, and other 3 materials are the calcium-based material. Okay, this is seashell waste. Then it is crushed like this, and this fibrous shows that this is amorphous in nature, and these gaps show that these are the pores in the adsorbent surface. This is XRD. Again, this shows these are the amorphous in nature. Then 51.65 is the calcium composition of that. So this is a calcium-based material. The point of zero charge of the adsorbent. A series of a 250 ml polymer flask of 45 ml of KNO3 solution of 0.1 molar strength was transferred. The pH 0 value of the solution were roughly adjusted from 0 to 40 by adding either 0.1 normal HCl or NaOH. This is adjusted by HCl and NaOH. The total volume of the solution in each class was made 50 ml by adding KNO3 solution of the same strength. 1 normal adsorbent was added to each class, which was securely clapped immediately. The suspension were then manually shaken and allowed to equilibrate for 48 hours. Intermittent shaking. The point of intersection of the resulting curve at which delta pH is equals to 0 gave the pH. We can see this. This is a 0 axis line. Here, this is one point. This is another point. This is again another point. This is third point. For groundnut shell, it is 7 pH, and for MP it is 8.9. For ESP it is 7.8, again SSP it is for 7.8 pH. Then batch study. Number one, effect of dose adsorbent for a groundnut shell. So here the graph is plotted between dose gram per liter and the percentage removal. As doses increases, the percentage removal also increases. The percentage removal also increases. From this, I can get this optimum dose is 4.5 for this groundnut shell. The reason is that as this is a surface phenomenon, so as dose is increasing, volume is also increasing. Volume increases, then surface area also increases. So uptake will be more. Then this is for the marble powder. Again, same. The plot between dose and percentage removal. Here again I am getting this 4.5 gram per liter. For actual powder, here I am getting my result up to in 5 gram per liter. And this. For facial powder, I am getting 4 gram per liter. I have combined this for comparative reasons. So we can this for groundnut shell and marble powder it is 4.5, and for egg shell it is 5. Then sea shell it is 4. Effect of pH is another parameter. Here we can see this graph is as pH is increases, percentage removal also increases, but up to a certain time it decreases. The reason is behind this. Since H ions and fluoride ions act together, they want to settle on the surface, but the priority will be given to H ions. So initially both will settle. Then up to a certain point, H ions will be take his position first. Then after that, he will allow to settle on the fluoride ions. So that's why it is decreasing here. Here I am getting the result as so the conditions are initial concentration at 10 mg per liter, dose is 4.5 gram liter for groundnut shell and marble powder. For egg shell it is 4.5. For sea shell it is 4 gram per liter. Temperature is 30 degrees centigrade, room temperature. The contact time is 24 hours, and the that agitation speed is 150 rpm. So here we are getting this at a groundnut shell near about 8 pH. Then it goes for from the graph we can see this from groundnut shell it will become near about 7, and for for marble powder it will be 8.9. For egg shell it will be for egg shell it will be 7.8, and then again for sea shell it will be 7.8. Thank you, sir. Then next, effect of initial concentration or adsorption of ground surface for a groundnut shell. Here we can see this, the plot is plotted between initial concentration and percentage removal. If initial concentration is increases, the uptake will also increase. The uptake will also increase, and hence the percentage removal gets decreases. So here the initial concentration is plotted for the. Here we can see this. This is the initial concentration, and these are the temperature variation. I have done temperature variation in this for 20 degree, for 30 degree, and for 40 degree. So, so for this, my actual concentration was this, and I am getting the reason. I am getting the results. This for 20 degree. Again for 30 degree, I am getting this one. And for 40 degree I am getting 12 to 40, in between 12 to.
How did you vary the temperature? The experiments?
Sir, we have orbital checking incubator in our lab, environmental lab. So initially I have set for 20 degrees centigrade and at the 150 rpm. Then next day I have done for the 30 degree, and again next day I have done for 40 degree.
Can you go below 20 degree?
Huh?
Can you go below 20 degree?
No, sir. because the natural water temperature is near about 20 degree, so that's why I have not taken below that.
Questions during presentation or after presentation? I don't know what exactly.
Whatever you like, no problem.
Okay, because I was a bit worried that your flow will be interrupted. That is why I did not ask you anything. Otherwise, I will ask you a lot of questions immediately. And many questions are common to both candidates, so
Yes.
I really do not know how to
Okay.
go about it. Because many things are quite similar. Anyway, who is the next candidate? Can I have a look at him? Okay. Nice. So what we may do, I may ask you some queries in between like this, but I prefer to address both together because mostly
Yes.
the work look quite similar.
Only adsorbents are
Yeah. So maybe both of you will present. Then I will try to minimize my introduction, and I will try my level best to minimize that, and maybe towards the end we can have a lot of questions. Okay. Okay. So you could not go below 20 degrees centigrade. Okay. Go ahead.
Then effect of studying on adsorption for all.
And one more thing for you, I would love to see slide numbers. So I think there is no number for the slides.
Yes.
So please insert. You are yet to come, so you can insert the slide number.
Yes.
Next time also,
You
please.
can see this. We have increased the RPM start from the 20 RPM to 200 RPM. Then for the groundnut shell marble border, these are the readings which show that. From this, we have get this. For groundnut shell, it comes between, it's come around 150 RPM, and for marble border, it comes 140. And again for eggshell, we have got readings near about 140, and for seashell again for 140. So I concluded that the RPM for groundnut shell will be 150 RPM. For this, it will be 140 RPM. Because after that, that will be no further percentage removal of is getting place. That's all.
If you show me a result like this, then you will have to certainly explain how RPM is going to play an important role. Because RPM is basically for mixing. You are speaking about the batch operation.
Yes, that's
And the time involved, what is the time involved?
the time is 24 hours.
24 hours. So in minutes, I think 200, 300, 400 in that range.
So there is again a time study is also there.
Okay. I know, time study is there. So can you explain scientifically how RPM is going to play such an important role?
So as agitation increases,
See, what I am trying to convince you is the moment you show us the result, then you have to defend it. Otherwise, don't show it. Okay. So, to me, RPM doesn't look that important. So, pH I can understand, pH, concentration of adsorbate and adsorbent, these things are important, but RPM, I know if you go to very low levels, perhaps it shows. At lower values, there is a significant influence, but towards the higher values, the influence is
very
perhaps.
constant.
Ah.
So since
This is only mixing, right? And what kind of adsorption are you speaking about? Chemisorption or physical adsorption?
basically chemisorption is coming to.
If it is physical absorption, then the result would have been the other way around, perhaps. More shaking, perhaps, if you shake vigorously, things may desorb. I don't know, you have to answer. So, what is the predominant process? Is it chemisorption or
This is chemisorption.
van der Waals forces or chemisorption?
Chemisorption. In my research, it is coming chemisorption.
Anyway, I understand my role. My role is actually between the candidate and the actual examiner. So, please don't worry, I am trying to help you only. My job is not to put you in trouble, but to help you. So, actually, I am bridging you and the examiner. So, I will try to give out my observation so that it will be good for the candidates. Okay? So, please don't take it otherwise. More questions you get, my explanation is more interesting you
More
about it.
inputs in there.
Okay, please go.
Actually, suppose here I am getting 150. So suppose if it is 160, 170, 180, up to 200, then there is no use of that. If suppose we are commercializing, then it is a wastage of energy. That's why it is necessary to do this agitation process. Then effect of time. Again we can see this curve. As time increases, percentage removal also increases, but it will be removed up to a certain time, but after some time it will be a constant. There was no.
I have a very serious problem here. I am really worried that you lost a lot of important information in the beginning. See, adsorption depends upon the concentration gradient. So initial few minutes were actually very, very important. I really do not know what is the fun in taking it for 1,300 minutes and 1,500 minutes. I would have been appreciating that if you had taken more values in the beginning. Like, so do we have a another plot for 0 to 100 minutes?
So I have gone through like this 15, 20, 60, 1.
Because this process is very, very, if you look at the rate of reaction is very prominent in the beginning.
Rapidly.
Because that concentration gradient decreases. Isn't it? So the data in the initial few minutes would have been very interesting for you. So have you taken those data or they are missing?
No, sir, I am not taking. I have started from this one.
15 minutes.
15, 30, 60.
So I would have been. These questions would come to you anyway.
Okay.
Be ready for the defense. Because initial few minutes are very interesting.
Okay,
Perhaps you have taken data at 1 minute, 30 seconds, or 1 minute, 1 minute, 1 minute, 2 minutes, 4 minutes, 8 minutes, like that. Then you can go to any number. Then there is no fun in taking, as you rightly have taken 15 minutes to make gradient, you speak it. But initially, it's very important. Those information are actually very interesting. Okay.
In 240 minutes, this is the equilibrium time for the groundnut shell. Then for marble body it is 360. For eggshell it is again 240, and for seashell it is 120.
Just put the previous down. Just be 0 to, I don't know, 10 minutes or 30 minutes or 20 minutes. We have reached the saturation.
So it actually rapidly increases, then it gets constant. Right? Then effect of dose with temperature. Here the dose is varying and temperature is varying. Since temperature increases the rate of reaction, that's why we can see this initially up to 5 ohm per liter readings will come. Then as the rate of reaction increases, then it decreases, the dose decreases. And for this is for marble border again, the dose is coming in 5.5, then it decreases 4.5, then again it decreases to 4 gram per liter. As temperature increases, then dose also decreases. Adsorption equilibrium study. To optimize the design of an adsorbent system for the removal of adsorbent, it is important to establish the more appropriate correlation for the equilibrium curve. Equilibrium isotherms are measured to determine the capacity of adsorbent for the adsorbent. The experimental equilibrium adsorption data of fluoride of the adsorbent at the outer surface of the adsorbent. The isotherm equation further assumes that adsorption takes place at a specific homogeneous site within the adsorbent. It is then assumed that one of the adsorbent molecules occupy a site, no further adsorption can take place at the site. In other words, we can say that there will be no further adsorption process. The linear form of the Langmuir isotherm is represented by the following equation. This is the equation which is used for that. Will give you C, that is the equilibrium liquid phase concentration. QE is the equilibrium amount adsorbed. QM is the maximum amount of sorbate. Then KL is the Langmuir constant related to that. Further, an extension of Langmuir equation was made by introducing a dimension equation parameter RL, which is called as a separation factor. These are the limits of the separation factor, which shows that whether it is favorable, linear, unfavorable, or irreversible. In our study, it is coming between 0 to 1, that is in favorable condition. QM is the monolayer saturation at a equilibrium. Kl indicate the affinity of the fluoride to bind with the adsorbent, and high Kl value indicate the highly affinity. In Friendwich isotherm, the Friendwich isotherm is derived by assuming a heterogeneous surface. This is the difference between both. In previously that was a homogeneous, this is a heterogeneous surface with a non-uniform distribution of heat absorbed over there will be a non-uniform distribution on the surface of the adsorbent. This model implies that the ratio of the amount of solute adsorbed onto a given mass of a solvent to the concentration of the solute in the solution is not a constant at a different solution concentration. It is represented as follows: Q is equals to Kf C E to the power 10, where Kf is a Friendwich constant. Friendwich constant Kf and 1 by n indicate the adsorption capacity and adsorption intensity respectively. Higher the value of 1 by n, the higher will be the affinity between the adsorbate and the adsorbent and the heterogeneity. Then third one is a Temkin isotherm. The heat of adsorption of all the molecules in the layer decreases linearly with a coverage due to adsorbate interaction. Desorption is characterized by uniform distribution of binding energies up to some maximum binding energies. Then this linear equation is given by Temkin. A plot is plotted between QE versus CE, which enables the determination of isothermal constant of KT and given. This is the graph for the Langmuir isotherm and the Friendwich isotherm. The constant are same. pH is equal to 7. The rotation per minute is 150. Agitation 150 rpm. Concentration is 10 mg per liter, and the contact time is 24 hours. So here we can say this: the plot is plotted between CE versus CE by QE, and the readings are getting good here. Here R square coefficient of regression is coming 0.96, 0.99, 0.99. So it is good. We can say this. It is follows the Langmuir, which we said that it is a homogeneous in nature. Then for Friendwich again we can see this. The equation again. These are the linear plots. So it plotted between LNCE versus LNQE. Again the readings, again the coefficient of regression, the value is 0.89, 0.97, 0.8. It also follows the Friendwich, which is heterogeneous. Both processes getting there. Then this Temkin, here also we are getting good result in 0.945, 0.97, 0.95. This is for the various temperatures actually. So that is tabulated in this way, where R square is the coefficient of regression, Km is the maximum capacity, Ki is a rate constant. Again for Friendwich, Kf is a rate constant, and this is 1 by n is affinity. Then again rate constant, this is also constant, coefficient of regression. So we can say this for groundwater, for grounded shell it follows both, follows for 3. Then separation factor is calculated here from that Langmuir relationship. Here the value is coming between 0 to 1, which shows that is a favorable. This is all for the 4 materials. Then for marble border again we can see this Langmuir is following, Friendwich is also following there, and Temkin is also following there. Langmuir is greatly followed, then the Temkin, and then the Friendwich. This is for eggshell powder, seashell powder. Again pattern is same. Then adsorption kinetic study. In adsorption kinetic study, we have gone through a pseudo first order, pseudo second order, interparticular diffusion, Ilovich equation and modeling, and the Friendwich equation. You see one by one. Pseudo first order, Lagrange rate equation, first model, is the most widely used rate equation to represent the adsorption process. Lagrange first order model developed for irreversible sorption in a solid liquid system. The pseudo first order model is given by this. Further, this is be converted in a linear form, and the graph is plotted between log QE minus QT versus T, which gives a rate constant. Then pseudo-second order is based on the assumption that chemical absorption or chemabsorption, one of the factor controlling in the absorption kinetics. In pseudo-first order, if it obeys, then that will be a physical absorption. In pseudo-second order, it obeys chemabsorption. The pseudo-second order model can be represented in the following this way. Then finally, that can be converted in a linear form in this way. Curve is plotted between time versus t by qt. The pseudo-second order rate constant Ks and is evaluated from this, and affinity is also evaluated from this, and Q is also evaluated from this. Then interparticular diffusion plot. Process may be one or more than one. The process may be external diffusion, pore diffusion, surface diffusion, adsorption on the pore surface, or it may be a combination of more than one. A process is diffusion control if its rate is dependent upon the rate at which the component diffuse towards the another. This is the equation for this interparticular diffusion. Whereas PID is the interparticular diffusion rate constant. Then I is a constant that gives the idea about the thickness of the boundary layer. As the larger the value of I, the greater is the boundary layer effect. If the Weber-Morris plot, this is plotted between Qt versus t to the power 0.5, certify the radial relationship. However, the data exhibit multilinear plot, then two or more steps influence the absorption process. This is represented by a first sharper portion. The second linear portion is the gradual adsorption state with the interparticular diffusion dominating. Then fourth one is Ilovich equation, and fifth one is modified French. Again, Ilovich equation also satisfies the chemabsorption process. Modified French equation was originally developed by Lotus. It gives this equation where Qt is the amount of adsorbent, K is the apparent adsorption rate constant, C is the initial concentration, M is the Lotus constant. This is a linear equation. From that, the graph is plotted between ln Qt versus ln T. Now, this is a model, pseudo first order model. This is pseudo second order model. Here I am not getting this. This model is not fit, so I can say this physical absorption is not over here. On the basis of this, I am saying that this is a chemabsorption process. Here the readings are good. R square value is getting closer to 1. And then this is the interparticular diffusion model. As we have seen in theory part, this can be a one or more steps. So here we can see the nature of the curve. This will be a one portion, this will be a second. Another in this we can see this also first and second. This is also first and second. It means we can say that it has a more than one step. Then Ilovich equation again, this satisfies at a 20 degree it is not satisfying, but near about at a 30 and a 40 it is satisfying. We can say this is again supporting to a chemabsorption process. Then modified French equation. Here the value R square value is like this. From this, the thickness is getting thickness of boundary layer is getting K is rate constant getting. From this we can say that first order is not obeying. Other than that, somehow they are obeying that models. Data is obeying that models. For this is marble border again. Pseudo first order is not good. In pseudo second order I am getting results. And again nature is like this, two step. And then Ilovich equation also supports in this chemabsorption. Then for modified French equation, for actual same is happening. For T-shell also it is happening same. Only one graph I found that it is the curve is like this, otherwise all are getting like this tapered and then like this. And then thermodynamic study. The thermodynamic parameter associated with the adsorption process, that is standard free energy, and that is delta G, which also gives energy. Then standard enthalpy change, delta H, standard entropy change, delta S. From this value, we can identify whether it is exothermic or spontaneous or feasible. The value of delta H and delta S can be obtained from the slope and intercept of the plot of lnk versus 1 by t. It is plotted, graph is plotted between 1 by t and lnk. From this, delta G is calculated, delta H is calculated, and delta S is,
What is K?
K is rate constant. From this, these values are getting here. I have clubbed this, and this is for the actual quarter. I have clubbed this data, and this here. What's up?
It's a common observation. To draw any graph, have to try to have at least 5 points. But you have only 3 temperatures, I suppose.
Yes, sir. Here I have only 3 temperature. Because 20 degree, 30 degree, and 40 degree. That's why.
The issue is with the 3 points, you just cannot draw. But of course, I know you have only 3 temperatures.
Yeah, I have worked for the. So
I am telling you in general, with 3 points, you really cannot. 5 will be would have been a good number. Anyway, good.
This is feasible and spontaneous in nature. This negative value of delta shows that this is exothermic in nature. If suppose it is positive, then that will be an endothermic in nature. And delta S is the spontaneous nature of a fluoride adsorption. Exothermic means which liberates the energy, and endothermic means the energy. Then physico-chemical characteristic of water sample. I have taken a field sample that was a 3.2 mg per liter. Then it is treated by the adsorbents, and all the readings are coming between this range 0.7 to 1. Then column study is done. Based on my adsorption batch study, I found that seashell powder is having a good adsorption values, or it is a optimum. We can say this is optimum adsorbent which is good in all respect. So I have worked on the seashell for the column study. For this, we have gone for breakthrough curve at a different bed depth for 10 cm, 15 cm, 20 cm. Here in x-axis it will be time, in y-axis CE by C0. From this is the service time which I am getting.
One observation for both of study. It is common for both of you. That is why I am trying to put it right now. I think there should be a kind of picture or a diagram. Try to give a diagram. Showing the dimension of the column, how long, what is the diameter, how deep this thing, and how do you supply the fluoride, adsorbate water using a peristaltic pump or whatever it is. Try to show a sketch, a schematic. That is very important.
Sir, we have designed a column.
Have you put it that sketch?
The graphical representation or schematics or figure, whatever you say, it is there. No. That is different.
Actual setup.
I have actual setup.
You should put it.
Sketch.
Okay.
I have picture.
And try to give some photographs also to add on to the real life feel of the picture. Okay.
I have.
So have not only not only the sketch, schematic dimension, but also a couple of photographs, just to have a feel of those things. Okay. That is one thing. Another thing is when you wind up column study, batch study for both of you, I would love to see a table. You told that seashell gives you maximum removal. So a table, before you go to column study, just give a table showing that what is the adsorbated, what amount is adsorbed, or what is the possibility of adsorption per gram of your adsorbent. I know it's a variable, it depends upon many things I know, but still that is the key. Like for 1 gram of adsorbent, how much is the quantity that can be absorbed? Give this feel of capacity. Give this feel. You have those numbers with you. It's not that you are on the way, you have those numbers there. But give a table to show this is the best. And of course, percentage removal also which is possible. But I want to have this number because this helps you in the design. How much is the quantity of fluoride absorbed per gram of adsorbent? seashell, what is it, marble powder, whatever it is. Then I think your column is actually arbitrary design, as I understand. Have you really designed it, or you have taken a column which is normal, in your case 2.5 meter there,
2.5.
in your case 3 points or something like that. So, and depth is 10 centimeter, 15 centimeter like that. So we have taken it arbitrarily.
Yes.
It's not a designed column, right? It would have been very interesting to show why you chose that numbers. There is a way to design it, or at least give the criteria what made you to choose these numbers. Because people can ask you anything. So you are actually have a feel of those things in advance. Okay? And also, since both of you are here, why did you choose, the same question is applicable to you also, why did you choose the fluoride concentration from 2 milligram per liter, 5 milligram per liter, 10 milligram per liter? Any reason for choosing that? Because I did not see in both of your report what is the normally occurring fluoride concentration when it is water is highly polluted. Do you have any values? Say from Andhra Pradesh, or there are areas of fluoride pollution.
I have shown that.
So it's okay. Can you tell me approximately what is the?
So actually what happened, in that data, minimum concentration and maximum concentration is there. So I have taken an average.
So what is the average?
That average is near about 10 mg per liter. That's why I have kept 10.
So in real life, the field it can go up to 10 ppm.
Yes. So I will show you that.
That is a. No, you don't have to show
In
me.
the range of 5 to 10.
5 to 10. So that is why you have chosen
Yes, sir,
that.
yes.
value.
That's why I mentioned.
So, for example, which area is having this kind of concentration?
Rajasthan is having
Rajasthan. And Andhra Pradesh also?
Andhra Pradesh is having high.
So that you have taken care of.
Yeah.
The concentration you have taken are actually field related. Okay, go ahead, it's okay, no problem. So go to columns.
To control the
No, that's
flow.
okay, but the permeability of the pack, how do you pack the column with your adsorbent?
Cotton and glass paper.
Huh. There's a pack.
At the bottom.
You did not compact it. You just put it.
No, I have inserted that tube and then I just pressed it.
And it doesn't have any supporting what is the particle size of adsorbent?
It is less than 75 micron.
Less than 75 microns. So was there any head loss?
Yes, sir.
So it looks like very fine powder.
Initially when I work, it comes along the flow.
No, but there is a obstruction below. The packing of adsorbent is there, and below there is an obstruction so that nothing goes down. Your thing was downflow or upflow?
Downflow.
Downflow. So you had some barriers at the bottom. I am asking about the packing of the adsorbate. Your powder, 70 microgram is a very fine powder.
Yes,
right?
it is very fine.
So,
Cement particles.
what was the permeability? Could you see water stagnant above your bed?
What is stagnant?
Or how long the column worked without a head of water above that?
So I'm not seeing that. I'm not
It's okay, but it's an observation. Because 70 micrometer is a very fine powder.
Yes, sir.
So if you use it as such, my worry is the head loss will be very large. So in case you want to use very fine powder like this, perhaps you need a supporting material like sand, for example. If you put sand and your adsorbent mixed together, then you can actually vary the permeability the way you want.
So I can show
Anyway, it depends upon.
I can show a sketch in 1 minute.
It's okay, we have a lot of time. He also has to present it, so.
We will see the column in the lab.
Actually, this is the water tank. And then what is
No, you understand these things, don't worry. I was asking you what is the technique inside, how it is done. There is a barrier here. Niche kya tha? Glass bowl. What was the
is like this, 5, 10, 15. And from that, we have calculated the optimized height. Since there are 3 bed Then we have got this optimum height. Then breakthrough curve at a different initial concentration.
You really cannot say optimum height.
That was
Go ahead,
calculated.
go ahead. You are telling larger the height, larger the removal. Yes, go to the previous slide.
So, if your depth is high, then surface time will be high.
Naturally.
Then from
If you
here, from
further
3
increase
depth,
the depth.
from 3 depth, this height is calculated.
Oh, okay.
This height is calculated from this BDST block.
Okay, okay, okay.
That's why. That's why.
Okay, take it.
Then breakthrough for initial curve.
What is the basis of the breakthrough? How do you, when you say it is breakthrough, is there any standard depth for breakthrough? Like,
So see, when
you are
it
just
is
plotting.
0.9, then that
you are just plotting C0
Yeah.
over C0.
I'll just plot.
C over C0. Okay.
Then disposal of Laden material. This is a very big problem, but
Once again. Again, my worry is the initial observations are lost actually. Where there is absolutely no pollution come out.
pattern was same. So in time study, that's
Previous slide? Previous slide? Okay, next. It's not taking a horizontal
It is getting
in the beginning.
No, initially.
I am more worried about the initial few minutes. So you are telling right after 0 minute, fluoride started coming out?
So there was a hold for that much time.
Okay.
The water is hold there for that much time.
Okay.
So from that.
Your time starts from the moment water comes from the bottom,
Yes,
or
yes.
when you start the experiment?
No, when water is coming out
Okay.
from that.
So what I am asking you, in the initial 5 minutes, 10 minutes, there may not be any fluoride coming out at all. Is that true? We have not checked.
At what time you have tested your...
When was the first reading?
Ah,
First estimation of fluoride?
after which time?
1 hour,
First time.
2 hours, 3 hours?
1 hour, 1 hour, 2 hour.
The rate is 10 ml.
No,
No,
not
right.
rate. When you have tested first,
You are putting water, fluoride water. Or did you wait for 1 hour to collect the
No, you have to
sample?
wait, sir. I have waited for.
Waited how long? That is the question.
how much?
When the bed is completely saturated.
First reading कब लिया आपने?
How much time is taken from inlet to outlet?
Hmm.
It will take more than 6 hours. When it is completely saturated,
No.
then it will come out.
No, what I am trying to tell you, Godbole,
Yes, yes.
the initial readings are important actually. Anyway, if anybody is pursuing similar study, initial readings are very important. You should note down the time required for water to appear from the bottom, and also you should start taking reading maybe after 5 minutes,
Yes.
10 minutes, 15 minutes in the beginning. Then later on it can be like this. 1 ghanta, 2 ghanta, no issue. But initial 1 hour or 2 hours are very crucial actually. Then the gram bagging is very different. So actually you lost a lot of information in the beginning. The same thing happened during your batch also. Please remember.
The time is
Huh. Because you are telling the CE equilibrium time is 120 minutes or what was that?
240,
Approximately.
120 and 120 in batch study.
Batch study. So I am telling you about the first 5 minutes. Or first 2-3 minutes. Yeah, 5 minutes for that. Okay. Okay, go ahead. Let's see.
We can reduce that concentration, so we use alkali or acidic, addition of alkali or acidic to neutralize that. So we have done that. Then about 85% of Laden is removed. 85% Laden is removed by washing and mixing alkali as reagent by using a certain additives, 0.1 normal HCl or NaOH. Adjusting pH by addition of HCl or NaOH. We can use lime also.
So did you try to use it again and again for adsorption cycles?
This can be used for regeneration also.
Huh. So how many cycles are possible?
2 cycles is possible in my study.
And in your case, it is 5 cycles.
This is 3 cycles. No, up to 6
You have
cycles.
gone up to 6 cycles.
Yes, sir.
And you are telling around 6 cycles.
Yeah, yes,
65%.
66 cycles.
65%
Yes, yes,
is
sir.
the, it has come down. In your case, two cycles only. Third cycle onwards,
No, sir. There's a reduction
that
of
means it has to be.
that is
Disposed.
Disposed.
Any suggestion for disposal?
We can just neutralize this and we
It's
can.
fluoride,
Yes, sir.
concentrated fluoride.
We have to reduce that level up to 0.7 to 1. And then we have diluted in water.
The adsorbent, sorry, spent adsorbent.
So this is very light.
Now ask me about the disposal of the spent matter, spent adsorbent, spent marble powder, spent groundnut powder.
Yes, sir. I have treated it with the.
Once it is exhausted, what is your proposal?
Where
does it go?
We can dispose on land. We can throw on land or we can drain
It's a
in water.
fluoride, na?
Yes, sir. But we have reduced that.
Are you sure it won't come out again?
No.
It can come out. Fluoride is sticking to your adsorbent. So, no, I understand. You are telling it can be regenerated for 2 cycles. Or
For 2
3
cycles it can be regenerated. But
After that it is spent, na?
no.
So
After
you have to
that
get rid of it.
we can discard because it cannot regenerate again and again.
So you have to
That's
dispose
all.
it off.
Yeah, we have
So I
disposed.
am asking you, how do you dispose it off? You should propose something for the safe disposal. कुछ लिखना है. Where does it go? See, the
So we
issue
can
is
dispose in soil just because it is not that much contaminated.
you cannot say that much contaminated.
Rain concentration का आप ले
See,
रहे हैं.
I can tell you any adsorption experiment. This is the question, which anybody can ask you. Not only me, anybody can ask you. See, you are actually from the big water volume. You are actually taking the pollutant and concentrating it to a small quantity. I completely appreciate that. The water is clean now, but you should tell us what are you going to do with this small quantity of spent adsorbent. Can it go to a landfill?
This can we go for landfill? This can we
Or
go
should
for-
it go to a hazardous waste landfill?
Yes, sir.
Or should it be put in a concrete matrix
Brick or concrete.
or a glass matrix or in a brick matrix and then go to hazardous? See, that depends upon the toxicity. So what the rule book says, please refer to the hazardous waste management rule books and you have to propose something. Now why I am telling you, this issue will be asked by any examiner. Because you can regenerate it. But is it worth regenerating? If it is worth, take a 5 bar kar lo, 6 bar kar lo, but one point I think you have to discard it. Then you should propose, based on the existing rules in the country, existing hazardous waste rule book, this should be treated like this and should go to sanitary landfill or hazardous waste landfill or solidification and then to a landfill, that you have to propose. I am not telling you to do. You don't have to do it, but you have to propose. Because then only the waste we can say, okay, it has been removed from the bulk water media and it has reached a place which is safe. Doesn't get into the environment. Otherwise, doesn't make any sense. Okay, don't tell again it will dilute it, again mix with water. These are all very dangerous statements. Okay, because it can leach out. In rain, if there is a rain after summer, this rain can bring in lot of acidic things. There are a lot of acidic gases. You have heard about acid rain. Every rain is not an acid rain, but rain can bring down acidic gases. So it can leach out and alternate high temperature, low temperature, high temperature, low temperature with water oozing through, it can come out. So you will be back to square one. You started with water and this is back to the environment. So be careful, okay? And both of you should address it very seriously. Okay, go ahead.
However, in the other two materials, that is crystalline in nature. In the case of groundnut shell and seashell powder,
I think this is common for both of you. Unfortunately, Godbole came first, so I'm just.
So it's applicable to you also. I may be wrong, but what initially I thought was, whenever we go for a kind of batch experiment like this, where you are trying to optimize pH, then dose, then other dose, then contact time, then again. My feeling is perhaps a cyclic approach would have been very nice. Because to optimize pH, you are actually taking some parameters arbitrarily. Then you are getting an optimum pH, say 7 or 7.5 or 8. With that pH you proceed. Then why don't you get back to pH once again and test whether the right pH you have got? Echo. You understood what I'm trying to tell you? You have done experiments, huh?
Yes, sir.
So, did you understand what I told you just now?
Yes, sir.
See, what was your first experiment? You optimized pH. If I am not wrong, both of you optimized pH. So, to optimize pH, you had some arbitrary concentrations taken, volume taken. Volume was arbitrary, concentration was arbitrary, dose was arbitrary, time was arbitrary in the beginning. Then you told the best pH, say 7 or 8 or whatever it is. With that you proceed, if I am not wrong. Please correct me if I am wrong.
Yes.
Then you proceed to the next round. You are optimizing, say, the dose. Then with that you are proceeding further, if I am not wrong. Then why don't you come back and check the pH? Cyclic, iterative. Iteration. So if you get back and do the pH once again and see whether you are getting exactly the same. So if you had done 1 or 2 cycles that way, iterative cycles, your result would have been beautiful. I am not telling you to redo the whole thing. Please don't take it that way. But if anybody is pursuing in the same line, perhaps these kind of things will be useful. Okay, that is why I am trying to tell you. So make it cyclic. Then another thing is, if you can design some experiments, if you can introduce some design of the experiments and some sensitivity analysis, it will be very interesting. Because you are telling that adsorption will be governed by the dose, absorption will be governed by the pH, which is more severe, which is more sensitive. There are so many parameters, so which parameter is more sensitive? So maybe in future somebody can do a sensitivity study also. For you it is too late now, so don't worry. So when you design the experiment, those who are trying to pursue in a similar manner, they can try to design the experiment and try to do a sensitivity also, which parameter is influencing more. Okay. So then one more observation is, this dose, optimum dose, to me doesn't make much sense unless you optimize the other things iteratively. Because dose depends upon your adsorbent concentration, and so I don't know whether you can really say this is the best dose. I hope you understood my argument. So people can put forward these kind of nasty arguments. Okay? Okay, go ahead, let us complete it because we have one more remaining. Next. Just reaction kinetics increases with temperature is okay, it's not a wrong statement, but there are many other parameters also that play a role. For example, how hydrophilic your pollutant is, and what are the surface properties of the adsorbent. So, rate of reaction could be on a general scale, or in a general way, perhaps we can say larger the temperature, larger the kinetics, but that is a general statement. But I am worried that you may have to probe into the finer details. Okay. I had asked him the same question, that boy. So he answered, sir, when temperature is low, adsorption is more, because I don't remember what exactly he told me. It has something to do with water-philic or water-phobic, and he was telling something about viscosity and all. Anyway, you have to, difficult to remember. I'm an old guy, I cannot remember immediately now. So be careful, this matter you may have to deeply probe. Find out some good reason. Okay? Okay. Please wind up. I think you are almost through, friends.
Yes, sir.
You are finding, please put the previous slide. You are telling which is the most efficient adsorbent. If you tell me, Professor Alapat, would you like to rate this adsorbent and tell us? Blindly, without doing any experiment, I would not have, without any experiment, just putting what is called our feeling. I would have rated perhaps marble powder. Sorry, what is the other one? Groundnut, marble, eggshell, and seashell. I would have put at the end. So I am proven completely wrong by your experience. I was thinking that it would have been the other way around. Surprising. But I told you, I may be completely wrong. I am just telling you with my intuition or whatever you call it. Intuitions are not always correct. Okay? So good. Go ahead then. Are you through? You showed some filter, water filter?
Yes, sir. This is proposed design.
Okay. For a household water filter.
Yeah, household. The depth which I have created, and I have.
So have you designed the porosity, the time, contact time and all? Or it is just a arbitrary design?
Yes, sir. This is what we are getting from column study.
Okay.
Okay. Then this is our time outside. And flow for the controlling of flow, there will be a flow controller.
Fine. I think you will see the other one also, and then I will give some general comments. Okay. Go ahead.
Thank you, sir.
Spoken with a lot of confidence and a lot of enthusiasm, and when I speak about my PhD topic after 20 years, I did it 20 years ago. When I speak about my PhD topic, I really feel possessive even now. That feel should come. PhD topic is a topic which is so close to your heart, on which you have worked. So that passion should come. So I don't know, I was not really feeling that passion when you spoke. Let us see the other part. Okay? So any PhD students completing PhD, the passion should come in your words and your body language. Otherwise you have not done a good PhD.